This is a demand curve. Downward sloping, the law of demand. That is to say that there's an inverse relationship between price and quantity demanded. So if price goes from P1 up to P2, quantity demanded will fall from Q1 to Q2. Here we have another demand curve. Downward sloping, law of demand. And if price goes from P1 to P2, we see again that quantity demanded falls from Q1 to Q2. We'll notice over with this demand curve that quantity demanded is quite sensitive to a change in price. Quantity demanded falls all the way down here from Q1 to Q2. Whereas with this demand curve, we see quantity demanded doesn't fall very far, just a little bit. Quantity demanded is fairly insensitive to change in price. Well, an example of a good that would probably be quite sensitive to a change in price would be Hostess Twinkies. I don't have to have my Twinkies. I'm not going to die if I don't get my Twinkies. I mean, I've got Ho-Hos, I have Zingers, I have donuts, I have Baby Ruths, got all kinds of things that I can get instead of Twinkies. But over here, well, a good that would be fairly insensitive to a change in price would be emergency medical services. If I have an emergency, I'm not going to care all that much about the price. Heart surgery. I mean, what's the substitute to heart surgery? Again, not that sensitive to a change in price. Home heating, same thing. We can cut back a little, but, still, not a whole lot. Well, what we want is a number, and we love numbers. We want a number that tells us just how sensitive or insensitive quantity demanded is to a change in price. Well, the most intuitive candidate for such a number would be just to take the change in quantity divided by the change in price. So, let's suppose that price goes up by 10, and as a result, quantity falls by 20. Okay, so again, we're just taking the change in price goes up by 10, and as a result, the change in quantity goes down by 20. Well, we divide 20 by 10, and we end up with this. Okay? So the reason we like ratios so much is the denominator always becomes a 1. So it tells us what a 1 unit change in price will result in terms of change in quantity. In this case, it goes down by 2. Change in quantity is 2. Well, when I say that when the price goes up by 1 unit and quantity demanded falls by 2 units, what are the units? Well, the units could be a lot of different things. Price could be in dollars, could be in yen, could be in British pounds, could be in euros. And if we change our units of measurement here, it's going to change our measure of sensitivity. And then we're left to wonder, well, did people change their behavior towards this good? Oh, it's just the units of measurement have been changed. So it can get really confusing. It turns out to be worthless if it's going to be that sensitive to a change in price. Same with quantity. Quantity can be in terms of weight, can be in boxes, truckloads, train loads. So anytime we change the unit of measurement and quantity, again, this whole ratio is going to change, and we're not going to know if people are changing their behavior towards a good or if it's just a change in the units of measurement. So that doesn't work out very well. This here, change in quantity divided by change in price, not a good measure of sensitivity. So instead, though, we can fix that by taking the percent change in quantity and dividing by the percent change in price. Now it doesn't matter if the units of measurement change, because the percent change won't change. This here is called the price elasticity of demand. So when we go up to this demand curve here, we observe this large change in quantity demanded. We would say that this good is relatively price elastic. Look how far it stretches. The quantity demanded stretches quite far. It's elastic. Whereas this good right here, quantity demanded doesn't stretch very far. We would say this is relatively inelastic.